The Higgs boson, the so-called God particle. It's a theory scientists have been chasing for decades. A subatomic particle believed to play a critical role in the creation of everything in the universe. They're announcing their findings tomorrow, but today, some of the scientists involved gave us an exclusive glimpse into their mind-bending research. Duncan McHugh joins us now from Vancouver. Duncan?
Diana, physicists here at the University of British Columbia can barely contain their excitement. They are part of a team of scientists around the world who believe they've found the holy grail of particle physics.
In this gigantic high-energy particle accelerator, a so-called atom basher located in Europe, physicists believe they've finally spotted something called a Higgs boson. In the physics world, that's like confirming you've got proof of a Sasquatch or a heffalump.
Because it's the first time anyone's ever tried to understand and been able to potentially answer a question as to where mass comes from.
What they've been doing is trying to simulate the Big Bang to explain an age-old riddle. How do elementary particles combine to create ordinary matter as we know it? The answer, it's long been theorized, is the Higgs boson.
The Higgs boson has this job of giving masses to all the other elementary particles.
The Eureka announcement to be made tomorrow. After years of effort, the physicists believe they've finally been able to observe the mysterious Higgs boson.
10% of it comes here to Vancouver.
The Canadian contribution, Triumph Lab at UBC, is home to one of 10 supercomputers that helped capture the massive amounts of data created by all those particle collisions.
And this is really a raw data of one collision event, 2 megabytes. But we do that millions of times every second. And so this is where the data is very, very large.
What does this breakthrough mean? Scientists say it validates key models of physics that explain how the universe was formed.
But it's really the intellectual challenge of understanding where matter comes from, how the universe was born, the ultimate fates of the universe that are driving this more than anything else. It's curiosity-driven research.
Now that they can see that elusive particle, the next step is to, guess what, study it. But physicists here are hopeful. The hunt can now begin to explain dark matter and dark energy and other questions about how the universe was created. Diana?
Thanks, Duncan. Duncan McHugh. Well, this is all pretty complicated for the layperson, so who better to explain it to us than the national science expert Bob McDonald, who joins us tonight from Victoria. Bob, help us understand what makes this so important.
Well, Diana, this is science at its most fundamental level, the kind of question that a child would ask. How did we get here? Where did we come from? And in the 1960s, Peter Higgs put out this crazy idea, maybe there was a particle that gave birth to everything else. But until you actually find one, until you actually prove that it exists, it's just a wild idea. So that's why they're excited. They know the science is right, that they're heading in the right direction to understand the very beginning of the universe. So it's a very large piece of this puzzle, but the puzzle is much bigger than that, and there are still more pieces missing that they have yet to find.
So where does this discovery take scientists next?
Well, as Duncan mentioned, they want to try to hold on to one of these bosons long enough to figure out how it did what it did to give mass to everything else, and they want to study other things. And another holy grail that I'm hoping for is another particle that's just theoretical at this point called the graviton. And the graviton is believed to be responsible for this stuff, gravity. We don't know how that works. And if we could understand it with a particle like the graviton, maybe we could turn it off. The way an electron can turn on and off electricity, we could make gravity go the other way. We could make it push. And who knows, maybe that would lead to warp drive, and we could be flying around the universe like Star Trek if we could understand one of these fundamental things about how the universe began. So it's kind of exciting to work at that very basic level.
And a fascinating explanation. Thanks, Bob, as always.